Alright guys, here we're going to talk about trigonometric identities. Yeah.
And the bell has rung, so class begins. Here we go. All right. These are going to be formulas you have to memorize. They're called identities because they're always true. One identity that you actually know that you haven't ever called an identity is when we square a binomial. The rule for squaring a binomial, as you know, is a squared. Square the first one, multiply the two double, and square the last term. And that is an identity because it doesn't matter what A and B are, that is always true. So here is another identity that we know. Now why do we know this is true? Let's remember from the last lesson that we knew that the point xy on the unit circle becomes the point cosine t and sine t. Okay, so what do we know about the tangent of t? Well, tangent of t is y over x. And look what your y is and look at what your x is. Notice that's where this relationship comes from. So the tangent of an angle can be written as sine of the angle over cosine of the angle. Likewise, cotangent of t is the reciprocal of tangent, so it's x over y. And since cotangent is x over y, notice our x is cosine theta on the unit circle, our y is sine theta, or sine of t xt. Okay?
So now we're going to simplify this expression by using these identities. Well, we know that cotangent is cosine of t over sine of t times sine of t. Well, cosine of t times over sine of t times sine of t, those two things cancel out. So we end up getting cosine of t.
There we go. We've simplified it, but if you don't memorize these rules, you won't be able to do that. Okay. Other identities we have are reciprocal identities. Again, we keep hammering home on this. It should point out to you that it's really, really important. Sine is 1 over cosecant, and by the same measure, cosecant is 1 over sine. Okay, cosine of an angle is 1 over secant, and secant is 1 over cosine. Likewise, tangent and cotangent have the same relationship. So we are now going to work. Think about this. We know the cosine. Now we want to find the secant and the cotangent. So let's look at secant. We know that the secant is the reciprocal. Secant of t is 1 over cosine of t. And that would mean, according to the information given, we have 1 over 0.75.
Which is not nice.
But we do know that 0.75 is 3/4. So now this becomes 1 over 3/4. Okay, using your complex fractions, we know that that's actually 4/3. So there you go. The secant is 4/3. Now let's look at working with cotangent. Cotangent is 1 over tangent. And we have the tangent value, which is 1 over, the tangent value is 0.88.
Now we know, because it's 88 100ths, this would be 88 over 100 would be the tangent, which simplifies to 22 over 25. So 1 over the tangent would be 1 over 22 over 25, which is 25 over 22.
See how easy that is? You don't need a calculator for it. Okay.
Alright, go into your textbook and work number 10. Alright, so here we go. We're going to talk about Pythagorean identities. We have sine squared plus cosine squared equals 1. We know that's true because in our right triangle, the leg squared, a squared plus b squared equals c squared. Well, in a unit circle, that's 1. So a squared plus b squared, sine squared plus cosine squared equals 1.
Also, what is it that we know in the unit circle? We know the sine of our angle is y. And we know the cosine of our angle is x. And do you see that this is really just x squared, y squared plus x squared is 1, a relationship we already know? Okay, sine squared plus cosine squared equals 1 is the same thing as x squared plus y squared equals 1 that we already know from the unit circle. So that's where that is actually coming from. Now, we have two other identities that are a little difficult. You think you have to memorize all these, but we say you really only have to know this one. And we're going to show you how to get to the other two by just knowing this one. If we take the basic Pythagorean identity and we divide the entire equation, every term, by cosine squared, now let's use our relationships. Our quotient relationship of sine squared over cosine squared is tangent squared. Cosine squared over cosine squared is 1, and using our reciprocal relationship, 1 over cosine squared would be secant squared. Okay, now another really important thing to recognize is that tangent squared, if we subtracted 1 from both sides, we could get that, or we could subtract tangent squared and get 1 equals secant squared minus tangent squared. Okay, those are very useful. We can come over here and look at the same thing. Once again, if we divide everything through by sine squared, we get 1. Sine squared over sine squared is 1. Cosine squared over sine squared is cotangent squared, and 1 over sine squared is cosecant squared. And again, we can write that cotangent squared is cosecant squared of theta minus 1, or cotangent squared, 1 is equal to cosecant squared minus cotangent squared, cosecant squared. Haha, yeah, minus cotangent squared of t. Okay? Now, why would we want to know this? Again, we can do the same things for our basic identity. What do you see right here? That is a difference of two squares. And how does it factor? 1 plus cosine t and 1 minus cosine t. No squared. No. We're tired. Let's try again. And there. So 1 minus cosine t squared factors 1 minus cosine t times 1 plus cosine t. And over here, likewise, that factors 1 minus sine t, 1 plus sine t, and there will be many times you're going to have to recognize that. So there's a lot of hidden algebra on this page. Okay, so let's use our identities that we just learned, and we're going to work this out two ways, okay? So divide your little set there by, leave room on both sides for two things. All right, first of all, let's rewrite the problem so we can show every single step. Okay, cotangent squared t times sine squared t plus sine squared t. What do you notice here? We have got a quotient. This is nice with the sine squared, and we can write cotangent squared as, in parentheses, cosine squared t over sine squared t times the sine squared t plus that sine squared t. Now notice, following order of operations, we would do the multiplication first and look at what we get. Cosine squared t plus sine squared t. Oh, cool, we know what that is. That is 1. All right, now that means that if we work this out another way, we sure better end up with 1. So let's rewrite the problem again and look at how we can think about it. Do you see that there is something common to both terms, a sine squared? So we're going to factor out the greatest common factor of sine squared, and that leaves cotangent squared plus 1. That's an identity we just learned. That is our cosecant squared t identity. So now we have sine squared of t times cosecant squared of t. How could we do that? Well, cosecant squared is 1 over sine squared. So now we have sine squared times 1 over sine squared. Those cancel, and boom, we still have 1. Okay, you are going to have to know your identities that well. If you don't have them memorized, you'll never be able to think creatively of how to use them. So you must have them memorized when you come to class.
All right, now go to section 6.5 in your textbook and work 1, 5, and 16. No calcs.
One of the neat things that happens with trig functions is the values repeat themselves as we move around the circle. Move around the circle. All right, so if we go around the circle one full time, starting at our angle and then moving around it a whole revolution, we end back up at the same point as we did before. Now when we start graphing these as functions, you'll see how it looks a little different on the graph. You're not at the same place, but you have the same values. So that's going to be very, very important. So a function is periodic if there's some number such that when I add it to our original angle, we end up at a place where we have the same value. Okay, and we'll show you a representation of this in a minute. So we know that the sine and cosine functions have a period of 2 pi, which is all the way around the circle, but tangent is different. Tangent, if you look in quadrant 1, we have the point xy, and when we go to quadrant 3, we have negative x, negative y. Well, the tangent ratio is the y coordinate of our point over the x coordinate of our point, and our y coordinate in quadrant 3 has a negative to it, and our x is negative, and notice I still get the relationship of y over x, which is tangent of t. So what this means is our function, tangent function, has a period of pi. All right, so once again, if we plot a point anywhere on the circle, sine and cosine have to revolve all the way around the circle for us to get the same ratios
for both of them.
For both of them, okay? Whereas tangent, any place on the circle that we go, all I have to do is go to the opposite quadrant and we will hit the same values. So notice sine and cosine and their reciprocals have a period of 2 pi, and tangent and its reciprocal, cotangent, have a period of pi. You need to know that.
Okay, so let's talk about even and odd functions. We know that even functions, when you plug in a negative x into the function, you get the original equation back, the original function back. And an odd function, when you plug in a negative x, you get the negative of your function. So when we plug in a negative angle to cosine, okay, that's the same as rotating it or finding the angle going the opposite direction on the unit circle. Okay, so if I do that, then my cosine, based on the fact that this is now in quadrant 4, is still positive. So that means the cosine of a negative is the positive cosine. Okay?
Yeah, it's got the same sign, SIGN value, okay? So the cosine of a negative angle and the ratio's the same. The ratio for cosine of negative angle and cosine of angle are the same, and they're both the same SIGN.
So that means it's an even function. Sine, on the other hand, whenever I go down with a negative angle, becomes negative. So the sine of negative t equals negative sine of t.
Notice that our sine of t in quadrant 1 is positive, but if we have gone the negative direction of our angle, we are negative. This also works if our angle is in quadrant 2 or quadrant 3 as well, so it applies.
So for tangent we would have a positive over a positive, and in the fourth quadrant we would have a positive over negative. So that means
a negative over positive.
Negative over a positive. So that means that for tangent, if I plug in a negative value for x, then I would get the negative of the tangent function. So that means that tangent is also odd.
And if you look up here, this is kind of like a mini proof. Let's look at this. Tangent of negative t is the sine of negative t over the cosine of negative t. Now we know that sine is odd, so the sine of a negative angle is the negative sine of the angle. Cosine is even, so the cosine of a negative angle is actually the cosine of the angle. That negative sign can come out in front, and what do we know about sine over cosine? It is tangent, so that is why the tangent of a negative angle is the negative tangent of the angle. We call that's just a little proof. So we know sine and tangent functions are odd, so are their reciprocals. Cosine is even and is reciprocal, so do you get the idea these are important concepts? Yes. So we are going to find the exact value of sine of pi over negative pi over 3, cosine of negative pi over 3, and tangent of negative pi over 3, and we're going to relate those to what we know about pi over 3. Now, if we look at pi over 3, we can visualize this triangle in our head. And the triangle that we see in our head, it's a 60-degree reference angle. Okay, and what we have is that the x-coordinate is 1/2 and the y-coordinate is the square root of 3 over 2. Okay, so let's think about the sine of negative pi over 3. You know what might be helpful is let's write out what our coordinate actually is. Our coordinate of our point is 1/2 and square root of 3 over 2, because now we can relate it to our x and our y. Our sine of negative pi over 3, because sine is odd, would be the negative sine of pi over 3. What's the sine of pi over 3? Square root of 3 over 2, so our answer is negative square root of 3 over 2. Let's use some similar reasoning for cosine. Set it up the same way. Cosine of negative pi over 3, since cosine is even, that is equal to the cosine of pi over 3. And cosine is our x-coordinate, so it's 1/2. And tangent of negative pi over 3, tangent's odd. Okay, so the tangent of negative pi over 3 is the negative tangent of pi over 3. Now we have to look at our two x's and y's here. Our y is square root of 3 over 2, our x is 1/2, so that is going to be the square root of 3 over 2 over 1/2. Those twos are going to cancel, and we have the square root of 3, and it's negative because of the negative sign in front of our relationship there. Okay, this is just a general, we want to throw it at you problem. How would we think about 2 pi over 3? I don't know, should we think about what quadrant that's in?
2 pi over 3 is 2/3 pi, which is about right there. Okay, this would be a reference angle of 60 because 2/3, well, 60 is 1/3 of pi, so this would be 120. So there's our reference angle is 60.
And
pi over 3.
Yeah, exactly. And we know what the coordinates of that point are now because we are in quadrant 2, x is negative, and this is our short side, so that's going to be negative 1/2. This is our long side, and that's square root of 3 over 2. And so how do we find the cosine of 2 pi over 3? Well, we have thought about it pretty much all that we need to think about it. It's going to be the x-coordinate right there, negative 1/2. The easiest way to do problems like these is to see that triangle in your head, draw it out if you have to, but you really have to know the unit circle and use your reference angle, which is what Ms. Miller did by stating that this angle here was a 60-degree angle and knowing how the triangle was going to look.
Okay, if sine of an angle is negative 3/5 and pi is less than theta and less than 3 pi over 2. Well, let's look at where that is. Theta is between pi and 3 pi over 2. This is pi, and this is 3 pi over 2, meaning our angle is actually in quadrant 3.
And it's useful at this point to actually write that down, that we know we are in quadrant 3, and in quadrant 3 we have negative, negative. That is going to be useful to think about that. Okay?
Okay. And if our sine is negative 3 over 5, well,
but
that
that's
means
not on the unit circle. We can't do it.
Well, this is still y over r.
Yes, it's a ratio of y to r. So we actually can do it without having to use a calculator and without flipping out.
So this is 3, and this is 5. And this is a 3, 4, 5 triangle because we know that that's a Pythagorean triple. That makes it nice and easy.
And we're in quadrant 3, so the 3 is negative and the 4 is negative.
So, what's the cosine? Well, the cosine of theta
is x over r. Well, maybe it would be useful, actually, once we've done this, is to write our point. Our point that this is terminating at is the point negative 4, negative 3. And that's why I usually write the point, because sometimes I get it in my head backwards, and if I take the time to stop and look at what the picture's telling me and what the point is, where that hypotenuse would end up, I reduce mistakes. We know that our tangent is y over x. You have your y, you have your x, so it's 3/4. Yeah, negative 3 over negative 4 is proper. Okay, now we have all the values necessary for finding our reciprocals. Our cotangent is the reciprocal of that, 4/3. Our secant is reciprocal of cosine, so it would be negative 5/4. And our cosecant is the reciprocal of the given value for sine, which is going to make it negative 5/3. Boom. Done.
Okay. So go to section 6.5 and work number 33. And these are the things you need to do. Don't forget to bring your entrance ticket to class.
This is the last section of chapter 6, so this is the last thing you'll be tested on.